Hey GPT, ask me some ML, Python, and DL questions.
Absolutely. I can ask you a few to test your knowledge or just spark some discussion. Would you prefer something more conceptual, like explaining a key idea, or something more coding specific, like writing a snippet?
I will try to explain the concepts.
That sounds great. Go for it. Just let me know what concept you want to explain, and I can ask follow up questions or give you some feedback.
I don't have any concept. You have to ask me the concept from ML, DL, or Python.
Ah, got it. No problem at all. Let me start with a classic. Could you explain what overfitting is in the context of machine learning and maybe how you can detect or prevent it?
Uh, Overfitting means when our model performing well on the training set, but it is like failing or it performing bad at the testing or unseen data. So we call it that's overfitting, and we can escape from it using cross validation, and there is an algorithm called random
Exactly,
forest.
that's a great explanation. And you can also mention things like regularization, like L1 or L2, or using simpler models to help reduce overfitting. Nice job. Would you like to try another concept?
Yeah, ask me another type of
Yeah,
concept.
sure. Let's switch it up. Could you explain what a convolution is in the context of a convolutional neural network and why they're so effective for image tasks?
CNN is a deep learning model that we use for uh, images, especially because it has a filter which moves over the images to extract the features like size, shape, line, curve, round. There are so many features we have in the image, so that's why we use it.
That's exactly right. And by using these small filters, the network can detect low-level features in the early layers, like edges or corners, and then in deeper layers it builds up to more complex patterns. So yeah, they're really powerful for vision tasks.
Ask me some Python question. Ask me some Python questions. Ask me some Python questions. Hello.
Of course. Let's do a Python one. Can you explain how list comprehensions work in Python and maybe give a simple example of one?
List comprehension. It's a quick way to make a list like by single line of code, like for
Yeah, go ahead.
I.
I'm ready to hear your explanation. And then if you'd like, I can ask some follow-ups or give you a bit of feedback.
Yeah, I was explaining the like what is a list comprehension. So list comprehension means it's a quick way to make a list like a single line of code. We can make a list like for I in range.
Exactly. Yeah, and perfect. So, for example, you can say something like if you have a list of numbers, you can create a new list with each number squared, all in one line, using a list comprehension. So,
Yeah,
it's both concise and really readable. Nicely explained.
yeah. So you can ask me some another questions and from the LLMs and from also from the generative AI, ML, DL, and Python. You have to ask me the mix of questions. Okay.
Actually, let's switch it up a bit. How about this? Could you explain what a transformer model is in deep learning and why it's been so influential in natural language processing?
Yeah, transformer. It's a deep learning model that is basically we use for the
Yeah, exactly. So, it's a
textual
deep learning
data
architecture that uses
because
attention.
it uses the attention mechanism that you have already told because attention focuses on the important word and it reads the word at once instead of seeing the data one by one like RNN and like LSTM and also we can use the
Yeah, that's
transformer which process all
perfect.
the
And
data at once. So it uses the like attention, it uses the attention and also like so many it has a architecture that it is uses a uh, forward feed forward
exactly.
network and also attention encoder decoder and masked attention and self attention. So these are the things that they always try to apply on the data, then it understands the data clearly and it gets some meaning from that.
Yeah, Yeah, absolutely. By doing that, it captures long range dependencies and context between words, which is a big reason why transformers work so well for language tasks. Great job explaining that.
So, can you give me the simple definition of a transformer and also feed forward network
Of
and
course.
self attention and also marked attention,
Exactly. So to
everything.
keep it Yeah, that's perfect. So, a transformer is a type of neural network architecture that relies heavily on self attention mechanisms to process input data in parallel, which is a big part of why it's so powerful for tasks like language modeling.
So, you can ask me the another questions.
Absolutely. Let's go for another one. Could you explain what a confusion matrix is in machine learning and how you would interpret it?
So a confusion metric basically it tells us that how the model is performing well and how the model is performing bad. So it has a error like type 1 and type 2 error we have. So here we can see that how our model how is the like correct prediction is going and how the wrong prediction is going. So we can easily see that.
Exactly. Yeah, and it typically breaks down into true positives, true negatives, false positives, and false negatives. So you can see where your model is making mistakes and where it's doing well. Great explanation.
Ask me 5 questions more and then we can end the session here practicing these type of questions.
Sounds great. All right, let's do a set of quick ones. First, what's the difference between batch gradient descent and stochastic gradient descent? Could you explain what dropout is in neural networks? Third, how does the train test split work and why is it important? Fourth, what is the perturbation function in a neural network? And fifth, what's a GAN, or generative adversarial network, and what are its key components?
Okay, so you have asked me batch gradient descent and stochastic gradient descent. So stochastic gradient descent it basically reads the data at once
Exactly.
or not
So
at once,
stochastic
it
gradient
basically
descent updates the model's parameters after each single training example, whereas batch gradient descent uses the whole dataset to compute the gradient before each update. Nice job. Ready for the next one whenever you are.
so batch gradient descent as you told and I was like trying to say that it basically reads the data at once and then we have a stochastic it reads the like data like one by one like one row at a time, I think. Am I right?
Exactly. Yeah, and batch gradient descent is stable since it uses all the data, but it can also be slower per update. Great. Let's move on to the next one.
So can you give me the definition of batch gradient descent, that what is this and
Awesome. So, no problem. So, next question, could you explain what dropout is in neural networks and how it helps with regularization?
dropout is basically we use in deep learning. We basically use it for the overfitting. If we have a overfitting in deep learning, then we use it dropout where we turn off some of the random neurons like 30%, so we can escape from the overfitting. And we can ask another questions. Few more left I know, but I forget what are these questions.
Yeah, exactly. That was perfect. So, the next one I asked was about the train test split, why it's important and how it works.
Yeah,
After that,
train test split is basically it's important. It's like a very important step of the machine learning where we tell our model where we tell our model that hey bro, this is our
exactly.
training part. You have to take the 80% data for the training and then you can use the 20% data for the testing. So here we are teaching our computer, this is the like important part. So and we also use the random state, I think that's a 42, so it can balance everything.
Yeah, exactly. That random seed ensures that the split is reproducible, so you get consistent training and testing sets every time. Perfect. Let's move on to the next one. What's the purpose of an activation function in a neural network?
Basically activation function in a neural network it tells that which information or which the information that we are getting after the multiplication and also which information we have to pass to the neural network, like forward we have to pass, which information we have to pass and which we have to ignore. So we that's why we use it activation function.
Exactly. Yeah, and it introduces nonlinearity into the network, so it
Yeah,
helps the
yeah.
model learn complex patterns. Nice
Yeah,
job.
because it
And then finally, what is a GAN and what are its
also
key?
gives us the non-linearity that help us to
Yeah, so a
uh,
GAN, or generative adversarial network, has two main parts: a generator, which tries to create realistic data, and a discriminator, which tries to distinguish between real and generated data. They train against each other, and that competition improves both components. Great job.